Right, so I live in Europe because I love Europe, but I have to travel a lot to California and around the globe. And so today what we want to do is explain how Nvidia is looking into that, coming from the technology. So, I mean, Silicon Valley, fast, there's a lot of hype, disruptions. We have started with the automotive industry and realized that we provide a GPU at the beginning. A GPU is just another technology which helps you to process in multiple commands in the same time. That means if you have to drive and you have a lot of sensors, you have to process these data very fastly. And that's why GPUs were very exciting at the early stages. Now the autonomous driving is evolving. When we started, car makers were telling us, 2030 maybe, or maybe 2035 when you see the first vehicles driving autonomously in the street. Every year we kind of shaped 2 to 3 years. Now we hear about 2021, and in the background people are working already on earlier. And how does that work? Right, so I mean, cars are developed in long life cycles, computer chips are developed like in 3 months, 6 months. One of the things we have adopted here is the idea what we generated in gaming. When we started in the gaming industry, coming up with new generations, we were wondering why the games were not getting faster. One of the reasons is that every time a game developer had to adapt their codes to a new generation, they had to start almost from scratch. So I have a déjà vu in this industry here too. Every time we're talking to transportation companies, even departments, like in Singapore we're talking to the Ministry of Transportation, in England, Department for Transportation, in Germany. So everywhere the same problem. Spent a lot of money, the research program has ended, and then the new program starts. There is no reusage from the previous program. Mm-hmm. Right, so everyone, you start from a new generation. The car makers pretty much did the same, or still some of them are doing the same. If you design a vehicle, one of the first questions the purchasing department is asking you is how much and how low power consumption. So still, you reduce the computing power to the minimum which is required to fulfill the applications you want to run on it. Now guess, if most of you have a smartphone, how much % of free space, power space is designed on the day one when a computer is launched? What do you think? If an iPhone 7 now, it comes to the market.
64.
So less than 50% is used really from day one. So they have another 50% designed for future. So if you look into your pods and buses and cars, how much space is designed for future? Maybe. And this is one of the problems. What we were able to attack with, not only us by the way, it's the whole industry, so Googles and Ubers, their approach is a different one. You don't ask on the day one when you start a development on the cost side and the power consumption. You say, what is the maximum power I can get today to start my development? So when I'm getting closer to my SOP start of production date, I can switch to the next generation or whatever generation is available and then optimize it. So it's a complete different way of developing, right? So this pretty much helped the industry to shape the development cycles. Now, it wasn't the large OEMs who shaped the time. It was companies like Tesla. When Tesla came up, I mean, you can debate if it's a good quality or not, if it's the same level. However, Tesla is the first company in the world at the moment who's updating applications and features over the air. I mean, all others are talking about it, but Tesla has done that. So what Tesla is doing, and some others now more and more coming up, is don't invent the technologies from scratch, because that's when you have a research, that's your intention. But if you want to do mass production or operational mode, you better use whatever is existing. You have a broad ecosystem, And by the way, I'm in charge in Europe for our ecosystem. So everything which is required to generate all that to supply to a car maker, that's our ecosystem. So for universities up to software companies, hardware companies, everyone. So what we do is we generate an ecosystem where we provide a platform, hardware and software, and say, whatever you develop here, you can exchange, inter-exchange. You can even, say this team is doing perception, this team is doing localization, this team is doing the back end, but it all works on the same architecture. So that helped. Now, a company like Volvo, which officially announced a few months ago that they will have on public streets the first fleet, around 100 or even more vehicles testing based on our platform. Volvo has not the millions like a BMW or Daimler has. They don't have 150 people just developing perception technologies. So how is Volvo able to be fast on the streets than the others? And the answer is they were not intending to develop every bits and bytes on their own. They were just trying to find the right ecosystem, start with the maximum power they could find, and that's obviously at the moment Nvidia's. I'll show you that one. Nvidia's computer. We are saying really supercomputer. This is a computer we have designed based on our OEM programs. So it's, we started with OEM programs. Every OEM wants to have a custom thing. We collected the inputs, and one of the major requests was, I need a lot of sensor inputs. So you have your 12 camera inputs. And then the next one is, I need a lot of power, really, really lot of power, because it's research, right? So that we have 2 Tegras here. One Tegra has 4 CPU inside. So it's a silicon on chip. And on top there is 1 discrete GPU, which is required to do multiprocessing. So the next question was, hey, I need a lot of I/O, so in-out interfaces. So we have I/Os for Ethernet. You can feed in over Ethernet a lot of different things like LiDAR information over Ethernet. But it has also 40 pins connector, which you can't see here. So it has CAN bus, it has FlexRay. All the car network which is required is ready here. Plus, and that was something what car makers want, they want to log everything what they do on the testing, they want to log. So we have a 100 gigabit Ethernet output here, plus USB 3. So this is a research platform. It's a computer, by the way. And because it was not fast enough, we put additionally 2 discrete GPUs on it. So it's kind of a boosting power. So like you have a gaming machine, but you have 3 graphic cards in it. Something like that. There we go. So this is where we have started, right? So I do a really fast run now because I was talking too much. This is where we are today. Now, why do I show this? I mean, it's not about gaming. This is obviously still 50% of our business. But meantime, we are not selling only graphic cards. More than 50% of our revenue is coming with services. Nvidia is the Netflix of gaming at the moment. But another reason is I want to switch now. The simulation is used already in the car industry. So most of the car makers are using our rendering engines to do testing. Now the link from that to tomorrow, there's I think an afternoon a slot which is about simulation and virtualization. Before a car is crashed, it is tested in the virtual environment. So one of the keys to get autonomous driving onto the street is to test it in the virtual environment before it gets onto the street. And this is what we do now with a lot of universities as well as car makers. They want to do the software and they test it in an environment, go back to the field, go back to the simulation. So one of the keys to develop autonomous software is to run it in the back end. Now, another message you can read. There are a lot of things people say, why autonomous driving, why automated driving. At the end, if you are a fleet owner, cost is the real driver. Safety, a great argument, but no car maker will invest in safety if it's not forced to, right? So the legacy, the government, all this is policy-making legislatives. They have to come up with the rules, and they have to say how to do it, and then everyone else will follow. But if you want to run a service like Siemens' colleague was saying, the business case is about costs. If you drive a car or you use a transportation, and you pay like 15 euro to the airport taxi, and you have a Uber, it costs you 10 euro. Now you see what happens. And if one of these transportation highest costs is the labor, which is more than 30%, and if you save that, so just imagine that you have a 50,000 euro cost for the driver per year. You replace that by an electronics that can be maybe 5,000 or 10,000 euro expensive, but it still will save a lot. So cost is key. The other one is 24 hours, 7 days it can run. And the third one, which also was by Roland Berger, they kind of made a really complicated calculation. They came up that the investment for the hardware environment at the moment today will return back in 3 years. So if you have a fleet, a truck, a city transportation, a people mover, whatever you do, and you invest in the right technology, and the technology is able to upscale later on, like the iPhone, you know. You don't start today with a limitation, you start with a bandwidth. So the way Tesla is doing that now for the next generation is they will set it up with all the sensors. It will come up with a highway pilot, but the electronics is ready to do full autonomous maybe in 2 years or 1 year, who knows. These are fields where we are already working. We're talking to all the car makers. Literally all car makers are using that platform to play around. All tier ones. And Volvo is one of the first we published. But interestingly, Uber is now buying Volvo cars, the setup, to do their own software on it. So Uber is probably kind of the most disrupting service company, transportation as a service company in the world. In China, it's Didi. So you have these big giants. In Europe, I was trying to find one, but I'm kind of struggling to find the real transportation as a service company because it's so fragmented and protected. But at a certain stage, there will be something coming in Europe too. So going further, Nutonomy in Singapore is one of our partners running into the autonomous taxi, so robot taxi, autonomous taxi, whatever you call it. But the idea is, here again, replace the driver, save a lot of costs, and then use that as I don't know if it's the last mile, but the most convenient mile probably. Vport is using EasyMile shuttles with a lot of intelligence, so that's a research program that is not intending automated driving, so not in the controlled environment really. It started there, but the software and the hardware designed is able to do full autonomy later. At the moment we start what we have and then we develop it to the next generation. And next week at the GTC in Amsterdam we will also tell or show at least a truck from DAF. We cannot tell too much, but the idea is that good transportation is where we see autonomous trucks really coming earlier into the streets than anything else, because that's where really the cost saving is about. Just imagine, and we're talking also to smaller companies who do transportation light trucks for cities. You know, also Singapore is interested in the idea of having overnight distribution of parcels around the city, fully autonomous, without driver, silent electronic vehicle. So these topics are ongoing. Nvidia is everywhere involved. And actually, maybe also I'm open. I will put my email address later on. We are acting like an advisory board to many organizations, like the National Research Organization in Germany, the transportation departments, but also whoever wants to do it, because we know at the moment globally what's going on. So if you don't want to reinvent the wheel, we could kind of give you some guidance if you want. So this is the world where I was listening this morning, where everyone is looking at. It's a controlled track. You know, you have either rail or you have some routes which are protected. Automation, this is not future. I mean, it's running over the last 10, 15, 20 years, whatever. It's still there. I guess that will happen too, but the next one is if you want to extend it into uncontrolled areas, what happens then? You have a lot of complexity. You see that one. At the moment, most of the shuttles I know, and I think I know almost all of them, they are limited in speed. They are limited in the tracks. They operate, but still in a very kind of closed environment with special approvals by the legislacy. So if you want to put these vehicles onto the street and say, you know what, I'll call my shuttle wherever I live, and then it will pick me up, and then we'll go to the airport or wherever. That kind of autonomous driving requires more than what we have at the moment. And the more is deep learning. I mean, I'm not going too much in deep learning, but it's about artificial intelligence. The idea of AI, it's not new, but it's at the moment just getting the right power to be deployed into the vehicles. The idea is to think, learn, and act like a superhuman. So you want to teach the computer that it is at least the same level of quality like the human being is, in a situation which you cannot predict. And how that works is demonstrated already in many times. So samples.
That's not 2 minutes.
2 minutes. I'm not going to the perception is seeing, so environmental. Now, what we launched here is yesterday. This is the middle part, and we did a smaller version, which I think could be very attractive for the shuttle business, because it is designed in a way that you can use the same software, the same I/Os. Everything is pretty much the same, but it's a limited. It's like automated driving is possible there. But the idea is when you want to grow up, you can kind of go up to whatever you need, and that's the computing model. Will this presentations distributed to users?
Unless you say not.
Okay.
Or you can derive.
I'll show you, because at the beginning so this is one thing. Please try to come over to Amsterdam. You will see all this in much more detail. We will talk about self-driving cars, but also deep learning. This is the one. So, teaching a car how to drive. How does it work? That's deep learning using 1px, one camera. It is watching the brake sensors. So the system is trained like a human driver would be trained. And the interesting part is at the beginning, obviously, it doesn't know what to do, right? So you have to do a full brake, you have to make a correction left, right. After a while, if you train enough, so it's about, the more you can train, the better it is. It learns really to keep the lanes. I mean, you see, the traditional software development wants to understand where the lane is and then makes a distance and if then. This one is just learning. It goes into areas which you wouldn't drive at the moment with your autonomous software. It makes it, okay, that's really, but it was kind of. This is the hardest challenge. I don't know any other solution which can really drive through that one. You cannot just write the software to do that. And then the one here, every car would stop, but this one understands that there is a road and that needs to go back. The thing is, you train somewhere and you take the same intelligence, like if you go to Italy, Iseo, Lake Iseo, and then drive around the lake, you never drove before, but you still know how to drive. Right, so that's about deep learning and how deep learning can enable autonomous driving. This is, I mean, everyone says autonomous driving in the night is not possible. It is. You cannot just write the software for it, you have to train it.
With a tropical rain?
Then, like in a Formula 1 race, there's a stop then. Right? Okay, I think I'm over the time.
No, it's okay. So thank you for your presentation.